Okay, it looks like it's recording. Hopefully it's recording. And I'm going to try to capture as much of the audio as I can. So, all right, so here we are, ready to go. Take it away, Katie.
Hi, everyone. Welcome to the season finale of the Distributed Network for Agricultural Monitoring. Exciting episode for you guys tonight. The characters that we're introducing. I am still Katie. I'm still electrical engineer. I was graduating hopefully next year.
And do you guys all try to speak a little bit louder than you normally do, just because we want the audio to be good. Okay. All right. So yell. Okay.
That's me. And we still have
Elijah. You've met me before.
I'd like to introduce everybody to Helen. This is our Capstone plant. She's very important to this project. She started her life as a centerpiece in the student center for an alumni event, and now she's dedicated her life to her Capstone project. So that's Helen. But more importantly, we also have our two guests here, starting with Felix.
Ja, hallo, also ich bin der Felix Ress. Ich komme aus Bayern und wir haben ja auch. I'm Felix Ress and I do speak a little English, so but yeah, I'm electrical engineering in Germany, and there Andreas and I study in Würzburg and Schweinfurt and Bavarian, if you hear that before. And in my hometown, my parents have agricultural machinery company, so that's why we have the connection to the agriculture.
Yeah, Felix sort of introduced me too. I'm majoring also in electrical and IT engineering in Würzburg. I do an apprenticeship as a mechatronics technician on the side, and yeah, we joined the team through the cooperation that was introduced to us. And my main focus in the project was backend developing the stuff. His main focus in the project was on the mechanical stuff and 3D design, testing the materials, stuff like that. Yeah.
So just as a quick project summary, in case you don't remember, our goal is to create basically an Internet of Things agricultural monitor. So you can see it up here in the front or in the picture there. Basically just a box you sit out in the field with a bunch of sensors that can monitor various agricultural parameters and then send them using the LoRaWAN protocol to our gateway, and then that ends up on the internet on our user-friendly website. And go for it. Okay, and as someone with agricultural background, the world population is increasing and we don't have unlimited farmland, so we want to make more food on the fields we have. So it's a precision monitoring system for precision agriculture.
So just to recap some of those project requirements that we've been working towards for the past 9 months, some amount of months. We want to do real-time monitoring, so we want to make sure that we're getting data from our plants, from our fields, that it's transmitting and that it's updating live on websites so we can see what's going on, what's happening now, in case there's any like staggering changes or anything like that. And we also want to make sure that we're able to do long distance communication at low power consumption. So we're looking at, thousands of acres of fields that need to be monitored. You don't want to have to install a Wi-Fi router every 20 feet. So long range communication, but then also low power consumption. That way we can charge it off of a battery and a solar panel. We're not running extension cords out into the fields or anything like that. And then of course we want to make sure that we have adaptability to various crop types. So we want to make sure that we have the ability to measure a variety of different parameters. pH may be important for one crop type and not the other. My begonias care a lot about how moist the soil is. This peace lily could not care less. Things like that. It's all dependent on the types of crops, and we want to make sure that we're adaptable to whatever you're growing. And then of course we have our user-friendly interface. If you have a bunch of data in a CSV file, that's great. What are you going to do with it? It looks like a bunch of numbers. So we want to make sure that we turn that into something that's actually usable for the common person. Which brings us into standards and constraints, everybody's favorite. So we have a bunch of different standards, and I'm not going to go into them all in detail again, because you've heard that and that gets boring pretty quickly. But I'm just going to highlight some of the things that we've taken into account really in the past little bit as we've been wrapping the project up. So we've got our long range wireless communication. Typically, IEEE 802.15.4 is looking more at wireless, like Wi-Fi and things like that, than it is LoRaWAN, but it's still important for us to look at how that's handled and managed, because LoRaWAN functions similarly, as well as we want to make sure we're not interfering with any expected Wi-Fi plans or anything like that. Then we've got 802.11, which is for your local wireless networks, which is what LoRaWAN is, so we want to make sure we're following that. And 802.11 has a European counterpart. It's ST 304-30892 or something like that. Don't quote me on the numbers. But says pretty much the same thing, but is in the standards for the European Union, and that defines the differences in the band ranges that we can use here versus Germany, which, as we mentioned before, has been a constraint, something that we've been working with, just with the different standards you have to meet. And then we've got ISO 5001, which is the energy management for efficiency standard, and then 9241, which is for human interfacing ergonomics and that industrial systems approach to things. So all of those we've been taking into account. We've been looking at pretty heavily in the usability and the sustainability of this project as a whole. And then some of the specific constraints that we've been dealing with. LoRaWAN RAN technology is not super accessible in the US. In Germany, they have these gateways pretty regularly throughout. They're easily accessible. Not so much here. We've got one here now. There's one in Birmingham, there's one in Atlanta, but that's about it. So in looking at wide-scale deployment of this, we have to talk about, petitioning for better infrastructure for LoRaWAN in the US as a whole. And then we have to talk about the durability of the project, right? You're putting this box outside, it's gonna be in a field, it's gonna rain, it's gonna snow, you're gonna hit it with a tractor. And so you wanna make sure that the box is as dependable and durable as possible. And so that also includes paying attention to the IP65 rating standards that comes out of the IEC. So we wanna make sure that it's dust tight and resistant, or and watertight, so water jets in case of rain, seepage, things like that. And then because it has to run on a solar panel, like we talked about a minute ago, we don't want a bunch of wires running out to the field. It's gotta be low power consumption. So we really worked on maximizing the efficiency of the code and of the project itself, so that we're sending data only when we need to, so that there's less power draw, battery lasts for longer. And then finally, with the development happening in Germany and in the US, well, it's not just the US that everybody's here. We've been dealing a lot with those regulated frequencies. We just, yesterday overcame an issue where we had something that worked in the German frequency but didn't work in the US frequency. So that has been a super fun, creative challenge to overcome.
So as for our project progress, you can see here we're pretty much where we want to be for the last week as we approach the Capstone Carnival. The power is completely done. It's working right now, running off of the battery, and if it was outside, the sun would be charging it by the solar panel. The hardware is largely done. I think we may still have a couple things left to solder officially for displaying at the Capstone Carnival. The firmware and software are the two things that, if any work needs to be done, it needs to happen there. Right now they work just fine, and they accomplish the basic goals of the progress, but there's still a lot that you can add to just the functionality of it. You can add more features always with the firmware and software. And we've had one issue lately, like Katie mentioned, with code that works in Germany but doesn't work in the US with downlinking. So there's still a little bit of firmware work that needs to be done on that, being able to receive updates from the Things Network, from our gateway, from the website. We still have some issues there, but it's not anything that really impacts the big picture of the project.
So our beautiful timeline that we've now shown 4 times. Just wanted to point out here that we're right here, we're right at the end. We're pretty much done. And it's been, I don't know, just a quick aside for me, I think it's been interesting and fulfilling, rewarding to get to the end of this timeline and be like, wow, that's a lot of gold bars that we've accomplished. All right, and so then let's talk about some of our decision making and why we did what we did, why we chose what we chose. And so what we have here are our beautiful decision trees. Yay, overly simplified to 2 inputs because it's unnecessarily difficult to make this type of graph. It's just so not. But talking about the power scheme, what we're trying to balance is sustainability versus efficiency. So, we want something that's sustainable, we want something that's low maintenance, but we also want something that uses that power efficiently. And so what we're kind of looking at is our main two comparison points are a wired structure, you know, you're plugging it in. That's kind of your baseline, that's what everything is, so that's what we used as our baseline decision maker when we did our little Q chart. Which is very reliable, but it doesn't do as well in sustainability because you have the dependency on power, which is not nearly as green. And then you have the maintenance of wires and things when you're out in the field. And then you also have really poor scalability. You know, that might work if you're just trying to run it in your garden and you already have an outlet outside. But as soon as you try to scale that up, you're running into big issues and lots of extension cords. And so that's just not really something that works for this project. And that's why we ultimately decided on this hybrid approach to the fast powering it with both the solar panel and the battery. Had we opted to just go for the solar panel, that would have been the most sustainable version of it because batteries obviously have to be replaced sometimes. There's hazards, chemical hazards with them. But then when it's dark, you're not getting anything. You're not getting any data at night, or if it's cloudy, or if there is, you know, a leaf, the wind blows a leaf over the solar panel, things like that. And that's just not something that you can really compromise on in order to still bring this project to its fullest extent. So solar panel and battery, it's a great compromise. It offers the scalability, it offers the sustainability, and you get the benefit of having power on demand when you need it, but also being able to charge renewably and not have to go out and change batteries, you know, every 2 or 3 days.
Yeah, so now to the data transmission. So when we thought about the project, similarly to the power scheme like Katie talked about, we needed something that is not dependent on existing infrastructure, or at least not that dependent on it. So, of course, something like Wi-Fi falls out of the possibilities because you can't like attach 20,000 Wi-Fi routers to your field to get your information from your IoT devices. So the next thing was cellular, which would be like one of the most common things today. But the problems with cellular is one, you don't have great coverage, especially in rural areas. And the other thing is you have like existing monthly costs. The third thing, and that is also important for the power scheme, cellular data needs a surprising amount of power. So that was out of the picture too. So then we looked at something called LoRaWAN. It translates into the long-range wide area network, which is basically perfect for our use case. With these gateways, you can cover really big distances with only one gateway, and yeah, it has a really low power. So, for example, when we tried it upstairs, the gateway is in the back of a workshop, so in the worst possible location. And we walked with our devices to the village, and we had no problem with reception there. So in Germany, you can go a bunch of kilometers without any miles. Yeah, okay, without any problems. Yeah, so that's why we stuck to LoRaWAN and implemented it into our project.
So on the website/user interface side of things, a lot of this development has really come in the last week. Unfortunately, we haven't run into any major this or that decisions. We haven't really had any huge problems. Good idea. But the main trade-off that we're focusing on here is functionality versus simplicity. Basically, just because of the time constraint. Everything largely works right now, but we want to add as many features as we can before Friday. But of course, you don't want to get so deep into something that you break everything and you can't fix it by Friday. So that's basically the trade-off here, is just trying to set our priorities and focus on the most important things that we definitely can get done. And we'll show you the website a little bit more here in a few minutes.
So mechanical design, there was the first question was if we want to dig a hole for the device and embed it, or should we make a spike like this? We decided on spike because when we would embed it, we don't have GPS and we could charge it with solar panel. And when it's on the field, we can see better. So this one is not coded as yet, but when we coded it orange, you can see it. And then for the box, we did testing with different materials because we decided to print a box, not just buy one. So we are flexible in size and where we need spacers to screw down any PCB stuff. And for the testing, we tested ABS. It was a bit brittle. And during our testing, it broke. Then we did PETG. You can't paint that really good, so it's not good for us because the painting is necessary for the UV protection also and water protection. And then we came up to PLA. With the coating, it went well to UV and heat and water proofness. So the decision was on that, and then we printed a gasket, PLO, TPU, and yeah, so now we have a box.
So last time we talked, we showed you a little bit of our phase 1 prototype. If you remember, it was largely successful. We could send data with a very limited range to our gateway. And we can get that to our website database. We had tested our 3D printed enclosure and we had tested our power components, but we still had a lot to do on sensor integration and especially improving the range and a lot of website work left to do.
Which brings us to our phase 2 prototype, which is what you're looking at before you. Right now, it successfully sends sensor data to charts on the website that update live, and you can change how much data you want to see, for how long, how many points of data you want to see far back. And then we have the 3D printed enclosure that houses all the hardware. So looking at this box right here, that's exactly what the finished product is going to look like. We just need to sand it, put it, and paint it. And then the lower end range has been greatly improved. You know, initially we were having to hold it really close. We couldn't figure out what's wrong, but just earlier this week, like last week, we figured out what our issue was there. And now, like I said, we walk over to the village. More impressively to me is that we can get connection to up in the ECE workshop staff area back there from this room. So we can get it all through the basement and everything that, I don't know, I feel like you can't even get Wi-Fi in the basement down here. So we're pretty excited about that kind of range. It really proved the viability of the concept that we were getting a little nervous about not working properly. And then, of course, we always still have room for improvement in the UI design, you know, whether that's updates to graphs, whether that's new sensors, whether it's more ways you can interact with your data, export and import, things like that. And then also sensor modularity. We have three sensors working right now. And we can get that data, we can transmit it, we can analyze it, we can pop it up on a graph. There's always room for more. We can do different types of sensors, we can do different levels of sensors, different implications and things like that.
While we're here talking about the website, I wanted to pull it up and show you. We've got it running. So this is like our short little homepage. You don't have to read everything, but I want to show it off because I finally updated it from pictures of my dog this week. This is our dashboard, which is where all the action is actually happening. So you can select your different lore links at the top. Each one of these represents a different box. We can set the location via the GPS and automatically get the weather at that location. We can click this button here to update the GPS coordinates. And then it looks like that one might have stopped transmitting. That one's working. So this data is coming in live. You can see it's 224 at the bottom. I hope you can see that. But that's data actually being transmitted from a sensor to our gateway, to our database, and finally shown on our website. And all of these sensors aren't completely, some of them are like not plugged in or whatever. So if you're seeing weird values, that's why. But come Friday, it'll actually be values that make sense. And we can select like a different time frame. Like I said, you can see some weird data there. Like this is just filler data as we were trying to get things to work. So we're happy with that functionality.
And if you look here, this little cap set up, you can see these little red probes that are in the Helen here, and then these green ones that come out. these are the actual sensors that are transmitted through this open breadboard here. We separated this out so we can kind of demonstrate what we're looking at. This is the box, it's all enclosed, and so that's where all of the electrical components will be housed and protected from the weather. But this is broken out on a breadboard so that you can see. So we have two sets of sensors hooked up to the plant right now, one going into the box as it will be, and then one going into this kind of open transmitting setup, just so you guys can see like what the actual circuit is. And then in terms of final updates, I think we've talked about a lot of this already, just kind of naturally in the presentation. But we've got the integrated solar panels and battery management system. So the LoRa link is entirely self-sufficient at this point. So a really big milestone that we finally hit. That feels really good. And then we've got website development, dashboards, and statistics pages, like Elijah showed. That page is much more updated, much more interactive than I think we might have actually just shown a rendering last time we were here. So now it actually like fully works. So that's another big update. And then we've got the sensor integration for the soil moisture, the temperature, and the atmospheric pressure sensors that are all sitting in the box.
And so where we could go from here, we can always add more sensors. And like Katie mentioned, we've got one that we're still having a little bit of trouble with. So we're hoping we can get that working, the leaf sensor. We can add a PCB. We had initially planned to do this, but the time constraints that got scrapped, and so we're focusing on like proto board soldering now. We can reduce our footprint. We could probably make that box a good bit smaller, but you know, it's the first prototype, so this is totally fine what we have now. And as we mentioned earlier, resolving the intermittent downlink. Sometimes we can talk to the box from the gateway, not all the time. So we've still got some firmware issues there from the transition from Germany to the US. And as I said earlier, we can always go further with expanding firmware and the website capabilities to do more and more for the end user.
And before we end and open up for questions, I just want to point out something fun about our sensors. So one of the interesting things about trying to do this sensor fusion, trying to integrate all of these different measurement devices and things like that, is that they all require different statuses with the plant and how they're integrated. So like, you know, these pH probes here, which are these red cap ones, you know, they have to be put in the ground, as do these soil moisture sensors of these green probes. But then this leaf sensor, you know, has to sit on top of the plant. But then the most interesting challenge that we've had to overcome in terms of how it actually works with plants is right here on the side of the box. I'm trying not to turn it too much without pulling a bunch of plugs out. But on the side of the box here, we have the DNAM sensor, which is what takes all of the atmospheric data, so temperature, humidity, and pressure. And so obviously that can't be housed inside because you're gonna have that excess heat from the electronics and things like that. But it also can't be just outside of the box because it can't get wet. So what do? And so what we've done is we've made a custom enclosure here that connects to the Deutsch connectors, which are these connectors that plug into the box. And the sensor is actually inside of here, and it's sealed with silicone to protect the wires and to make a waterproof seal. But then it also has drainage on the bottom side. That way we can get the atmospheric data, via the temperature and the pressure and the things, because you have those ventilation holes, but you don't have the collection of water inside to protect the sensor. And then that just plugs into the side of the box, like so.
So, any questions?
Very impressive project. So is I don't remember the technical from the audience or what the narrative was, but the LoRa, is that the thing that's sending out your signal? What are you talking about? Like if there's one burning and one in the kitchen?
Yes.
Is that the LoRa?
Yes, that's the lower end gateways.
Okay, the gateways. So is it like a security purpose for it being in that? It just seems like it's in a very inconvenient place for y'all with the way that you were talking about. If you get back into the security purpose, if that's why it's placed there, or what's the purpose behind this?
They wouldn't let us put it on the roof. That's why it's there.
It was an Auburn IT thing. We had to go through a lot to get them to let us set up a new network, even though it's not like Wi-Fi or cellular or anything like that. And so now we can run it in the back room. We can run it in other parts of Brown Hall, but we try not to move it around too much because sometimes the IT people get mad when they see a new network.
Okay, it is.
And we mentioned that we were getting connection from the village. In reality, we should be able to get much further connection than that. It's just because it's sitting in Brown Hall, it's got all this concrete and trees and campus noise in the way. So from the village inside a concrete building we're really happy with that. Before we couldn't get out of the room, so we're glad we got that fixed.
You mentioned that you had like range issues and you just now figured them out. What was the issue? How you figured it out?
So the firmware for the connection was mostly developed in Germany, where we use another band. So there are channels and there are bands within LoRaWAN. So actually, when they used it here, the firmware had the right channel, but of a wrong subband. But because the subband were right next to each other, they overlapped a bit. So when they were right next to the gateway, it would actually submit data, but we were sitting like 3 meters away, or I don't know what. And we couldn't get a good connection to it, and it took us a long time to figure it out because you don't think of that because you sometimes get a connection, but sometimes not with the same configuration. Yeah, so it was a subband and a timing issue mostly.
Any other questions? All right. Well, fantastic. Thank you so much. Appreciate it. So.